Hello all. In this video session we will be discussing about bubble sort. First of all, what is sorting? Sorting means we are arranging the elements of a list or array in a certain order, that may be in ascending order or in a descending order. Okay. So bubble sort is a sorting algorithm that repeatedly steps through the list, compares adjacent elements and swaps them if they are in the wrong order. Okay. The pass through the list is repeated until the list is sorted. Okay, so just consider that we have an array of elements and we want to sort it in ascending order. Okay, so in each pass the adjacent elements are compared, and if they are not in order, means that in ascending order the element at the left hand side should be less than the element at the right hand side. If they are not like that, then they will be swapped. Okay, and this will be done when all the adjacent elements are compared. Okay, so if there are n elements, then a maximum of n minus 1 passes are required to sort that array using bubble sort. Okay, so now this is the logic for performing the bubble sort. First loop, that is I equal to 0, I less than n minus 1 plus I, is for controlling the number of passes, and there will be n minus 1 number of passes. Okay, and now the second for loop, that is using j, is for actually considering all the adjacent elements of an array. Okay, so here first we will be taking j equal to 0, then we will be comparing the nearest adjacent element on the right. That is why we have given if a of j greater than a of j plus 1, if the element on the left hand side is greater than the element on the right hand side, then they are exchanged. So these three statements are for actually exchanging, are used for exchanging the values of a of j and a of j plus 1. Okay, so this is for the comparison, this is for the swapping. Okay, so this loop is for number of passes, this loop is for comparing all the adjacent elements of the array, and this is the actual comparison operation, and these three statements are for swapping. Okay, now we will just go through this code with the help of an example. So for the example, consider an array A with 5 elements, so n equal to 5, and it is containing the elements 2, 5, 4, 3 and 1. Okay, first we'll look on the how it works, then we come to the code. Okay, so this is our array in the initial pass. So in the first pass, the a of 0 and a of 1 are compared, and we are checking where a of 0 is greater than a of 1. The condition is false, so no change. Then we will be comparing a of 1 and a of 2, next two adjacent elements. Here a of 1 is greater than a of 2, so we will interchange. These two elements are not in order. Okay, so we will be interchanging. So 4 will come here and 5 will come here. Okay, 4 comes here and 5 comes here. Next, the next two adjacent elements are compared, so we will be comparing a of 2 and a of 3. So here also a of 2 is greater than a of 3, so here also there will be interchange. So 5 will be coming here and 3 will be coming here. Okay, now the next two elements are compared. Okay, so here 5 and 1 are compared, 5 is greater than 1, so again we interchange these two elements. Okay, and finally we will be getting these values. So when we reach at this point, we have compared all the adjacent elements, and the largest element is bubbled to the end of the array. Okay, so after pass 1, 5 is placed at the correct place, or we can say that 5 is bubbled to the end of the array. Okay, one of the reason why this sorting method is called bubble sort, because the largest element will be bubbled to the end of the array. Okay, so now we will see the loop for comparison of adjacent element in each pass. So here we have started from j equal to 0, then we have compared 0 and 1, then 1 and 2, 2 and 3, 3 and 4. Okay, so we are comparing a of j plus a of j plus 1. So we have to only reach till 3. Okay, so 3 means it should have to only come to n minus 2. Okay, so that's why here written j equal to 0, j less than n minus 1. Okay, here I equal to 0. So that we will see in the next pass, the use of minus I. So in here we are comparing a of j with a of j plus 1, and if the element at the left hand side is greater than the element at the right hand side, then we will be swapping the elements. This is the code for swapping the elements. Okay, so value in a of j will be placed in a of j plus 1, and value at a of j will be placed at a of j plus 1. Okay, so this is the code for interchanging the values of a of j and a of j plus 1. Okay, so I hope why you understood the concept of why j is less than n minus 1. Okay, since we are considering j and j plus 1, when we reach here, here will be the value of n will be n minus 2, that is 3, and then when j becomes 4, we don't have another element to compare with. That's why the loop will only go till j less than n minus 1. Okay, so this is how the loop works in our first pass. Now we will see the second pass. Okay, so in our second pass, okay, we'll come to the logic. Here I equal to 1. Again the same loop and same comparisons. So here the last element is placed in the correct place, that is at the end of the array. So it doesn't require to compare that particular element. Okay, that's why here a minus I is given. Anyway, we'll just continue with the operation. So here a of 0 and a of 1 are compared. This is in correct order, so no change. Then a of 1 and a of 2 is compared. It is not in correct order, so they will be swapped. Okay, so interchange, you will get 3 and 4 interchanged. That is the element at position a of 1 and a of 2. Then a of 2 and a of 3 are compared. Here also a of 2 is greater than a of 3, so they will be interchanged. Okay, so it will become 1 and 4. So here after reaching here, we can say that after pass 2, 4 placed in correct place. Okay, so even if you don't give this minus I, it will work, but you know, after pass 1 we got the last element as the largest element, so we doesn't require to compare this element. Okay, that's why here minus I is given, and in the next pass we don't have to compare this last two elements, and in pass 4 we doesn't require to compare the last three elements, because last three elements will be in the sorted order. That's why here given j less than n minus 1 minus I. Okay, now we will continue with the operation in pass 3. Okay, this is the code. Okay, these are all the same code. Here just the value of I is changing. Okay, so here again a of 0 and a of 1 compared, it is in order, so no change. Then again a of 1 and a of 2 are compared, it is not in order, so they are swapped. So 1 and 3, and the last three elements are in order. Okay, so after this we don't have to compare the last two elements because they are already in order. Okay, so after pass 2 we got the last three elements in order. Now again going to the pass 4, here value of I equal to 3, so we will be only comparing a of 0 and a of 1. It is not in order, so interchange. So here 1 comes here and 2 comes here. Okay, so here also in pass 4 the last three elements are already sorted, so we doesn't require to compare those. That's why here given j less than n minus 1 minus I. Okay, so just remember that when we are performing bubble sort, if there are n elements, it will be sorted after n minus 1 passes. Okay, and also at the end of each pass the largest element will be bubbled to the end. Okay, in the first pass the largest element will be the bubble to the end. In the second pass the second largest element will be bubbled to the second last element of the array. And after the pass 3 the third largest element will be bubbled to the third last position of the array. In fourth pass the fourth largest element will be bubbled to the fourth last position of the array. This is how the bubble sort works. Okay, you should exercise with few other values and find out how this works. Also you should remember that it uses two for loops to perform bubble sort. First one is for number of passes and second one is for performing comparison with adjacent elements. Okay, so in our array if there are n elements we will be comparing adjacent elements. So a of j is compared with a of j plus 1, and if there are n elements there will be n minus 1 comparisons required. Okay, so 0 to n minus 2 means there will be n minus 1 comparisons, but after each pass we will be getting the largest element at the end. So as the pass increases, the number of comparisons required will be decreasing by 1. That's why here j less than n minus 1 minus I is given. Okay, so remember about this code. Okay, thanks.